We want to practice a little bit more how to make 118 elements. Double left click the start button, then double left click nucleus and push this little screen aside. Double left click on P+, that gives you the hydrogen 1 nucleus, or that is an element that has only one proton. And if we add another proton, we get the element helium, but now we have to add a neutron to make this stable. So we have now 2 protons and 1 neutron in the nucleus, and this is called helium-3 because we count the protons and the neutrons, and we call this the mass number. Double left click on the do button. This will give us some choices to look at. Here you can see the mass number A is the number of protons and neutrons in the nucleus. The atomic number Z is the number of protons. We also have a neutron number N, which gives us the number of neutrons. And the electric charge, in this case, as we don't have any electrons, it is the electric charge of the nucleus. And in our chart, on our table here, the electric charge is the 2+. The 4.0026 is the relative atomic mass number AR that you find in your periodic table listed above the symbol of the element. We want to practice more what the relative atomic mass number AR is and how it is calculated. The relative atomic mass Rm, symbol A, subscript R, is equal the weighted average mass of the isotopes of an element divided by 1/12 of the mass of one carbon-12 atom. And chemists have defined 1/12 mass of one carbon-12 atom as 1 U, or as it is often called also 1 AMU. Let us calculate an example. Copper has an atomic number Z equals 29. So it has 29 protons in its nucleus. And there are 2 naturally occurring isotopes, Cu63 and Cu65. Cu63 has 34 neutrons, so the neutron number is 34, and Cu65 has 36 neutrons. Cu63 has a mass of 104.492 multiplied by 10 to the power of minus 27 kilogram, while Cu65 has a mass of 107.812 multiplied by 10 to the power of minus 27 kilogram. So you know now that there are 2 isotopes of copper, Cu, in nature occurring. The chemists call the percentage of isotopes you find in nature the natural abundance, abbreviated Na. If you take a random sample of 100,000 copper atoms, you will find approximately 69,000 Cu63 atoms, that is 69% or equal 0.69, and 31,000 Cu65 atoms, or 31% equals 0.31. These numbers 0.69 and 0.31 will be the weights for the mass of each isotope. Here you have all the information you need to calculate the relative atomic mass of copper. Cu63 with a mass of 104.492 multiplied by 10 to the power of minus 27 kilogram, and the weight is 0.69. And Cu65 with a mass of 107.812 multiplied by 10 to the power of minus 27 kilogram with a weight of 0.31. We can write this information in the following way: the mass 63 copper, the weight 63 copper, the mass 65 copper, and the weight 65 copper. Now we can calculate the weighted average mass of copper, that is equal to the mass of 63 copper multiplied by the weight of 63 copper, and add to this the product of the mass of 65 copper multiplied by the weight of 65 copper. And the result is the weighted average mass of copper is 105.5212 multiplied by 10 to the power of minus 27 kilogram. To calculate the relative mass of copper, we need to take this weighted average mass of its isotopes and divide it by 1/12 of the mass of the carbon-12 atom. The mass of a C12 atom is equal to 19.92648 multiplied by 10 to the power of minus 27 kilogram. If you divide that by 12, you get 1.66054 multiplied by 10 to the power of minus 27 kilogram. And physicists and chemists have defined this number as 1U, also one uses MU, AMU, which stands for the unit Unified Atomic Mass Unit. Defining a unit 1U and calculating everything in 1U's makes it easier. You don't need to say always 10 to the power of minus 27 kilogram and so on. Let us think what this 1U or 1MU means. You know that C12 has 6 protons and 6 neutrons, so it is 12 nucleons. It has 12 nucleons. Therefore, mC12 divided by 12 is equal to the mass of one nucleon that is bound in a carbon-12 atom. This is an average mass for all the nucleons, but you always have to say bound in a carbon-12 atom. Now we can calculate the relative atomic mass for copper. The numerator we have already calculated as 105.5212 multiplied by 10 to the power of minus 27 kilogram, and we divide this now by 1.66054 multiplied by 10 to the power of minus 27, and we get a number that is 63.5463, and this number has no unit, and please check your periodic table for 29 copper, and you will find exactly for the relative atomic mass 63.5463. Now I want to practice what I have just learned. I double left click the start button, I double left click on the do button, and a lot of information appears here. Here down there you find the weighted average mass of all stable isotopes, and that is the first thing we are going to calculate. The weighted, we have here the weight for copper 65, we have here the mass for copper 65, and here we have the weight for copper 63 and the weight for the mass 63. What we had to do was, we had to multiply the weight of copper 63, the mass of copper 63 with the weight of copper 63, and we add to this the mass of copper 63 multiplied by the weight of copper 63. So that's essentially all what we have to do. And here you see this result would give us the weighted average mass in kilogram. So here the mass for 63 copper, the number appears down here, is 104.492 multiplied by 10 to the power of minus 27. That we have to multiply by 0.69, which is the weight, and 69% of all copper atoms in nature have a mass number of 63. And then to that we add the copper mass for copper 65, which is 107.812 multiplied by 10 to the power of minus 27 kilogram. And we multiply that by the weight of copper 65, which is 0.31, which means 31% of all the copper atoms that are appearing in nature are copper 65. That is, now we have everything what we need in the numerator. Now we have to calculate the denominator, and we take the mass of carbon 12, and the mass of carbon 12 we can always double click to get something. If there are two dots on the left hand side, you can double click and get, and we know that this is 19.92648 multiplied by 10 to the power of minus 27 kilogram, and we divide this now by 12. So here we have the number 2. And that gives us 1.66 multiplied by 10 to the power of minus 27 kilogram, which is equal to 1 U, also called MU, Unified Atomic Mass Unit. This is a definition of a unit, like this is called the Unified Atomic Mass Unit, and 1 U is equal to 1.66 multiplied by 10 to the power of minus 27 kilogram. Now we just have to calculate the relative atomic mass A subscript R, AR, and we know that AR is equal to the weighted average mass of all stable isotopes of copper, and we have calculated this up here, divided by the mass of a C12 atom divided by 12, And when you calculate this, you get 63.5463, which is the relative atomic mass of copper, and you find that in your periodic table of the elements. Practice this a few times for perfect understanding. Thank you very much.